Good morning, students. Welcome to online video lecturing class for control engineering. So in the last video we have discussed about some of the basics of Laplace transformation, what are the advantages of Laplace transformation, and how we can use those Laplace transformation to define the mechanical systems. Also we have seen some of the basic elements for the mechanical system, that is discussed about the mass, spring and damper. We have gone through how to write the differential equation for the mass and spring and dashpot. That is, what are the forces are causing the displacement or velocity or acceleration for those elements. So today we'll try to solve some of the simple examples, that is how to make the mathematical model of the given mechanical system. So let us begin with the first problem. So here is the statement: draw the equivalent mechanical system for a given system and write the differential equation and obtain transfer function. So whenever we ask you to write the differential equation or he asks you to obtain the transfer function, the very first step is you need to draw its free body diagram. Before that, you need to analyze the elements of the given system, that is, which are the masses, spring and damper, and where exactly the input is given and what is the output because of that input. So here, if you see, this is the given problem, that is mechanical system. It is having mass, spring and damper. And here he has not given input as a force and he has not mentioned which is input or which is output. So in such cases you try to assume from any one of the end. So here if I analyze from this end, this is going to be the x, that is the displacement which is occurring at this end. Okay. So I will take this x as the input, that is input displacement. Because of this input displacement, the expansion of spring will take place. Along with that, this m is going to have some displacement. When these together they are moving, obviously this damper will also have some displacement. So now we will take this x as input and y as output. So before moving further, first you need to draw the free body diagram. So free body diagram always you have to draw for the given masses. So here in this given system you are having only one mass. First draw that m and try to analyze which are the forces acting on this mass m. Okay. So here the x is applied at this end and the displacement of this mass m is y in upward direction, right? So when this mass m is trying to move in upward direction, this damper will try to resist that motion, right? So show the direction as downward direction. So this will be b into y dot. And here on this surface, no doubt, whenever if the mass is trying to move in this direction, no doubt this spring will try to resist, but this spring is at the free end. Okay. For example, instead of in this system, instead of having the free end, if it is fixed to any one of these surface, that time obviously the spring will try to resist that motion. Okay. And for example, if this mass n has to have some displacement in y direction, okay, so any one of the force should act in the same direction, right? So for that reason, this force direction will be upward. Why? The force due to damper will be downward, because it will try to resist, because it is fixed here. But k is not fixed, it is a free end. Okay. So now b into y dot, as we have discussed while discussing the analysis of the mechanical elements, that is how to write the force for the mass, force for the spring, and force for the damper. So here always the force is proportional to the velocity. Velocity means y dot. So b into y dot. Here it is k into x minus y, because this k is between x and y. So whenever you are having a spring between two displacements, so that time you have to write the difference between, that is difference between these two displacements, because this force is directly proportional to the net displacement of the spring. Okay, so for that is the reason why here x is the input, y is the output, so it will be x minus y. So after drawing this free body diagram, the next step is you need to draw the equivalent mechanical system. So as we have listed 5 steps, so the very first step is, first you need to identify the number of displacements. So in this given problem there are 2 displacements, that is x and y. Okay, so first you need to mark those 2 displacements, that is x and y. Now after that you need to identify the elements which are associated with the individual displacements. Okay, so here for this x, no doubt k is directly connected, but it is between 2 displacements x and y. For this y is directly connected to m and b. So attach these 2 elements to the node which is represented by y, m and b. After that, this k is between x and y. So you have to show that k between x and y. Then you have to show the fixed surface. So this is going to be the equivalent mechanical system. So first step is identify the number of displacements, then identify the individual elements which are associated with those displacements. Attach to them. If there are intermediate elements like k, show them between the displacements. So after drawing the equivalent mechanical system and free body diagram, the next step is you need to write the differential equation. So here the statement has not mentioned which is the output or which is the input. Just by analyzing those given system, we can take y as the output, the x as the input. So applying Newton's second law of motion, that is says that the acceleration force will be equal to restoring force, or sum of the all forces and reaction forces must be equal to 0. So applying that Newton's law, and by considering this free body diagram, okay, so here acceleration force is always, it will be due to mass m. So I will write it as m into y double dot. Okay, so its direction always, it will be in the direction of displacement. That is why m is moving upward, because the direction of y is given as upward. So the acceleration force will be upward direction. So m into y double dot will be the acceleration force, which is equal. Then on this side, you write the restoring force. So here, if you observe that free body diagram, there this b into y dot is acting downward direction, but where mass is moving in upward direction, acceleration force is in upward direction. So with negative sign you have to take minus b into y dot plus k into x minus y. So y plus to this k, because this spring force is acting upward, acceleration force is also acting upward. Okay, so here you have to be very careful while taking the sign, when to take the negative sign and when to take the positive sign. Okay, then simplify this one, m into y double dot, bring this term to this side, plus b into y dot plus k into y. If you bring this one to this side, it will become y minus x is equal to k into x. Now for this differential equation, take the Laplace transformation of the equation. So here it is y double dot means d square y by dt square. So for that, to write m is a constant as it is m into y double dot, and replace it as s square into y of s, plus b into y dot is there. So you can write b into s into y of s, because it is like dx by dt. We used to write s into x of s. In the same way, here we are writing plus k into y of s is equal to k into x of s. So here in these terms, y of s is common. So take that term as common term, is equal to k into x of s. So here, as we had defined earlier, y of s is the output and x of s is the input. So our transfer function definition, this definition is, it is a ratio of Laplace transformation of output to input. So here output is y of s, input is x of s. So taking that ratio, y of s divided by x of s is equal to k into ms square plus ds plus k will be the transfer function for the given problem. Okay. So now moving further, second problem. So for a given mechanical system, determine transfer function. So even though in the statement it has not mentioned write the differential equation or draw the equivalent mechanical system, the duty is always you have to have the practice of writing the differential equation and drawing the equivalent mechanical system. Okay, if you want to find out the if you want to determine the transfer function, basically you have to write the differential equation for the given system. That is mandatory. Along with that, always make a habit of drawing the equivalent mechanical system. Now, first we'll try to, this is the given problem, we'll try to draw the free body diagram. Okay, so for mass m, we are going to draw the free body diagram. Again here, displacement is applied at this free end. Okay, so and m is connected to spring K2 and B, that is a damper, and spring K1. Okay. And x is spring in positive x direction, in this direction towards right side. So now, as I was told earlier, if this mass m tries to move in this direction, obviously these damper and spring will try to resist that motion because they are fixed here. So the direction of those two forces will be in opposite direction. So it will be b into x dot k1 into x. On this end, obviously you should have some force. So that is the reason why I am showing the direction in this direction. So it is k2 into y minus x, because y is the input and x is the output. So we have to show in opposite direction. So this is the free body diagram. After that, we need to draw the equivalent mechanical system. So again, number of displacements are 2, that is x and y. First mark those two nodes x and y separately. Then try to identify the elements which are associated with individual displacement. So for the example, for this x, which are the elements are associated, x is directly connected to this m, b and k1, because these two are in parallel combination. So obviously they will have the same displacement. So m, b and k1 are having x as the displacement. So attach those three elements to node x. Then this k2 is between x and y. Show that k2 between x and y. Like this, and this connected to fixed surface. So this is the equivalent mechanical system. After drawing the equivalent mechanical system, you need to write the differential equation. So applying the Newton's second law, mx double dot, that is from this free body diagram. Yeah. X is occurring in this direction. So acceleration force will be in this direction. So take the forces which are acting in positive x direction as the positive, the opposite direction as the negative. So mx double dot equal to k2 into y minus x minus b into x dot, because they are acting in opposite direction, minus k1 into x. So simplify to get one displacement on one side and another displacement on another side. So mx double dot plus bx dot plus k1x plus k2x is equal to k2 into y. So take the Laplace transformation of this equation. So x double dot is to replace it by s square into x of s, x dot as s into x of s, x as x of s, k2 into x of s is equal to y as y of s. So in these terms x of s is common, so take that term, we will left with m square plus bs plus k1 plus k2 is equal to k2 into y of s. So again here y is the input and x is the output, so transfer function is output by input. So x of s by y of s, take this ratio, you will get it as k2 divided by m into s square plus bs plus k1 plus k2. So this is the transfer function for the given problem. Now moving further, one more simple problem. So this is the given mechanical system. Okay. So here instead of giving the displacement, he has applied some force, that is F, on this end. So first step is you need to draw the free body diagram for this M. So here I forgot to write the M, it is M. So F is, you are applying that F in a downward direction. When this mass M tries to move in downward direction, the spring and damper will try to resist that motion. So the direction of those forces will be opposite this. Okay. Now try to draw the equivalent mechanical system. Since there is only one displacement, that is x. Okay. So, and all the elements are associated with x only. So draw one node and to that node attach M, spring and damper at one point only. Then this end you need to apply the force, that is input F of t. This is the equivalent mechanical system. Now applying the Newton's second law, acceleration force always it will act in the direction of displacement. So displacement is occurring in the downward direction. So now the forces which are acting in the downward direction, you have to take it as positive and upward direction as negative. So here mx double dot is the acceleration force, which is equal to F. I have taken this F is positive because it is acting downward, but the acceleration force is also acting in downward direction, minus kx minus cx dot. So simplify to get the displacement terms one side and force as the other side. So mx double dot plus kx plus cx dot equal to F. So apply the Laplace transformation for this equation. You will get it as ms square into x of s plus cs into x of s plus k into x of s is equal to f of s. So try to take the common terms. This x of s is common, take that term outside. You left with this equation. So transfer function is output by input. So x of s divided by f of s, because here f of s is the input, that is applied force. Because of that applied force, the system is having the displacement as x. So x of s divided by f of s is equal to ms square plus cs plus k. So this is the transfer function for the given system. Okay. So in the next class, we'll try to solve two more problems where you are having the more number of displacements or different kind of inputs, that is force or displacement. And here in all the examples, we have not considered the friction. Okay, because as we are discussing about the element of mechanical element as a friction, that is the damper, or whenever a system is having a motion, there will be some friction. So here we assume that friction is 0. But in the further problems, we will try to consider that friction into account and what all the effects of that friction on the to get the transfer function. Okay. So if we have, so here first, whenever we gives you the problem, should be able to draw the free body diagram along with the directions. So you have to be very careful here. If you fail to draw the correct free body diagram, then your entire solution is going to be wrong, because these directions are important. Okay. So always try to analyze or try to draw the free body diagram by analyzing the system from any one of the end, so that you will come to know which force is acting in which direction. Okay. After drawing the free body diagram, you have to draw the equivalent mechanical system. Then by using that Newton's second law, you have to write the governing equations, that is differential equations. Then it is simple, just you need to apply the Laplace transformation. After that, you need to take the common terms, that is, you try to get the input terms on one side and output terms on the other side, then try to get the ratio of output over input. Okay. So try to go through these problems. If you have any doubt, leave a comment in comment box. Okay. So in the next class, we will try to solve 2 more problems so that you can understand in a better way. Thank you.